Hi, ladies and gentlemen. We are back with the SAP IP Business Talks. Today, we talk about something a bit different from our normal discussions, which are pretty much IP centered. So today we have real engineers with us. We talk about AI-powered engineering, a fascinating topic which really changes at the moment in many industries the way how we think about creating inventions, but also innovations, and how to adapt to this huge AI boost. I have two, three housekeeping mentions for you. So first, we are live on LinkedIn. That means you can ask questions. I'm happy to get your comments, and I will try to answer to that during the show when you want to ask something to Thomas or Rick or me. And of course, we are here for you, so don't be shy. I'm happy to bring you in the show. We are today three. We have Rick with us, Rick Rasor, and we have Thomas with us, Thomas Meenken. So, typically, for the ones who know my show for a longer time, I ask the guys, how did you came in the strange field of IP? But in this time, I will ask you something different, a bit different. Thomas, how did you become an engineer?
Yeah, that's an interesting question. So thank you very much for the invitation and to be here. But I was, I think, born as an engineer. So my grandfather repaired radios and televisions at that time. So directly after the war. And when I grew up, I always was interested in how he did that. And I built my own circuit boards when I was young. And I wasn't so limited to electronics. So I always felt, interested in things, how they work. Why does a plane fly? How does all the engines work? And then also did my first jet engine in the basement, which was not so funny for my parents because, of course, there are some burning liquids involved, and if you're 10, that's not so funny. Yeah. So I think I'm really an engineer. So I also studied then engineering, applied physics in Germany still, but then I had the feeling of, there's something else in the world. I need to go somewhere else. And so I moved over to Canada to continue my studies and did a master in mechanical engineering and simulation, where I did tests and experiments on an aluminium ingot with a new cooling technology. So also physics combined with electronics and software. And this is also what I always kept in my working field. It's always a combination of software, mechanics, and electronics. And although I have now over more than 30 years of experience in R&D, I still an engineer. So in my private life, I built a 3D printer myself completely. And I also developed an IoT solution for my RV because it was parked out far away. So I had to know when the current was stopped so that's not getting freezed. And I'm still doing the designs and development of PCB boards, soldering, and these stuff. Which just gives me a good feeling also when you do strategical decisions, how can they be implemented? Because I still know how to implement them by myself.
Got you.
Yeah.
Got you. Fascinating. So what is with you, Rick? How did you become an engineer?
The true story, it was a coin flip. So it was a choice between chemistry studies and mechanical engineering, and yeah, it was really coin flip. But yeah, I would share some of the passion that Thomas has. So I'm also kind of the for the German audience, the Daniel Düsentrieb. So I love to disassembly stuff, and yeah, this was also the reason why I think technical studies was my direction. After it, I also spent several time in a more production related industry, so really working with machines, CAD/CAM integration and stuff like that. But then somehow I feel more interested in the invention, creating, designing part. So I moved to the product engineering. Spent several time at applied research, especially in topics like model-based systems engineering and product lifecycle management, where at the end of the day my heart gets stuck to IT stuff and more software engineering than mechanical engineering. It's faster, and especially fascinating was a part of AI, right? And for this reason, I'm now for 1.5 years building a company in especially this field.
Yeah. I mean, that is what we want to talk today about, these interplay between AI and engineering, which is absolutely fascinating. So you have a company. You founded Schlatek, and this is about AI-powered engineering. So before we come to that in detail, so could you introduce a little bit how you combine, on the one side, these consulting, so enabling others to do so, and on the other hand, the implementation, concrete projects when we talk about AI in engineering? What are you doing there? Very concrete.
Yeah, thank you. So the approach is, of course, first of all, enabling people who are already motivated to do that. So sometimes we also need to motivate them, but the first part mostly starts by enabling this. Could be we start with a workshop, but normally people also come directly with the use case to us. And then, of course, the first entry is to do kind of consulting and say, yeah, you have these options, we have a use case, and we show them already made solutions. And then I think the winning point, the USP that we combine, is we don't stop at PowerPoint. So we do the consulting part, we show them how they could solve it, and then we solve it for them. And this is also where Rick and his team plays a crucial part, because they are then develop the solution, the prompts, the plugins, the AI solutions for them, and we run them on their system, and they go productive and live with that. So, and we don't stop until we have proven the business case so that the savings are earned. That is really our unique selling point, where we come in. We just don't advise and say how it should work. We make it work. And this is also like what we can reuse and for other companies say. Of course, we keep it private, the information, but there's a transfer possibility in that we use. So use cases are often comparable between companies. And so we have this know-how and say, yeah, we know about how long it would take to implement this. And then we can also say how long it would take to implement it at your place.
Okay. So in my world, there are still people out there who say AI cannot be inventive. Okay, and I mean it is over the time this contribution goes down, but still there are many people who think an AI cannot be truly inventive, so to speak. I mean, we found new antibiotics. Okay, we create the big companies, pharma and chemical companies create daily new compounds. We have new materials which are all created by AI and which was simply not existing before. So I think it is obvious that you can be very creative and you can be inventive with AI, but still we have people out there who say Gen AI is just, probability of a certain word after a certain other word, and that is not creative per se. However, when it comes to AI and engineering, what is your perspective on that? Is it so that is it just automatization, just probability, or is that really something which can enhance the creativity in engineering? For example, when you want to test or to design new solutions. So what is your perspective on that?
May I take that? And first of all, I think a very crucial thing is that if we're talking about AI and engineering, both of it are more like umbrella terms, right? So it is really a big field. Maybe from an outside perspective, it feels like a niche, but it's really a huge scope that we could cover. And I mean, what could be helpful if we first of all show what kind of possibilities are there. And we prepared one image with a V model, which we might show that shows where we can really apply AI to enhance stuff in general, like creativity. And that said, I would first of all say that the main idea for us is not to invent the AI from scratch, rather than using what is out there to apply it on problems in the engineering domain, right? What you can see here, hopefully some people may aware of it, is a typical, let's say, sketch how an engineering or development process would look like. In the real world, this may take 5 to 20 years, depending on the complexity of a technical system. But I mean, typically people from outside see an engineer as a totally creative person that stands all the day on a whiteboard inventing things. But the real world is that we have redundant work. We had a lot of documents that have to be handled. And to give you just one example, current AI solutions like large language models could help in the first field where you have to specify a technical system. Rather than looking through hundreds or thousands of pages of a technical description of a technical system, you may use existing AI solutions to make it faster, make it more goal-orientated, and then use this, let's say, free time that is now there for the engineers to be what they want to do, be creative, and to build better or more innovative system. So maybe to close this monologue, it's important to understand what we are doing. We are not focusing putting AI into the product itself, rather than in the method, the underlying process of developing the technical system of the future.
So my understanding is that you use AI, Gen AI, to help to develop a product. Is that correct?
Right, that's correct. And as you stated before, the main benefit, of course, relies in these process optimizations. So at the end, you save time. You do more in a shorter time. And this is also what companies need today, because development times have been raised due to rising complexity, and also to the rise of regulatory topics they have to face. And AI can help to speed this process up. So of course yes.
Yeah.
So of course, we focus a lot of automation, which is the core. But here's also a funny story. When I really thought about what is the main benefit of applying AI in these processes, I did a kind of hypothesis and asked AI, I think it's automation. Can you rather prove or reject these theory? And the AI went through, did a deep research, and said, yeah, you're right. I found a lot of evidences that the automation is the main part of introducing AI. However, you forgot one thing. And the one thing was, I can be creative. So, and then thinking about it, going more in the details here, you have some processes where, for example, you want to compare documents, where you have regulations in, if it's in there or not, you don't want to be creative. But on the other hand, if you do kind of design optimization, you need other designs. If you do kind of a risk analysis, you want the AI to be creative. So it needs to be capable of thinking that what can all happen, where can I, crush my fingers or my feet when you dealing with a robot or something. And from our experience, AI can really well do it. And also there's also technical background for this. You can also steer this creativity by the temperature. But maybe Rick, you want to explain more on the basics on that.
Yeah, I think that is exactly the point. So on the one hand, we argue that there is this hallucination, okay, which is at the end of the day nothing else than creativity. Okay, so something comes out which I did not expect it, and that is basically a creative act, and that has something to do with the temperature,
Yeah.
what you expect from the machine.
Right.
And how does that work, Rick?
Yeah, maybe we can go a little bit into that detail. I mean, just as an introduction sentence, I would assume that most people nowadays, thinking if we're talking about AI, they have like a chat assistant that they use in a browser, for example, in mind, right? Something like the typical systems, Gemini, ChatGPT, and stuff like that. And the core thing of these is that they're based on so-called large language models, which are not really the same kind of technology as AI was 10 years ago, right? It was machine learning, decision support, right? But now we're talking about the generative part. So it can create stuff out of scratch. And what we every day see on LinkedIn or wherever we want to see, people doing poems, they're doing funny images, they use systems for making memes out of it, right? And this is creative part, right? It's just a tool to support this creativity. And now the main thing is poems work well, funny images works well, technical drawings, specification documents, system models still not work that good. And this is where we came into part, because we are using, for some projects, existing chat windows. They're total open, available for everybody, and show how you can control these kind of systems to apply it for engineering domain. And you can use, for example, for specific tasks, for example, if you want to have just let's say a categorization, you want to slice a PDF for 3 departments, you don't really want to have creativity or hallucination. You can reduce the temperature. You can make it more repetitive or deterministic. At the end of the day, 100% is not probably madeable, but close to. And it's good enough to solve this use case. If you, for example, want to have a smart sparring partner, right, to discuss an idea, to discuss architecture, should I choose, let's say, component 1 or component B? What's up with pros and cons? You may want to have this creativity intended, right? Because it's the same as you would discuss with a colleague, right? And this is what we
But
actually, yeah.
Just what comes into my mind is, so I can assume, so what I already did is that I discussed 3 mechanisms with the AI. So obviously the AI knows 3, and then you can apply them to solve a technical problem. What is with physics? So is it so that there is this fascinating problem that the AI should make a picture of a watch, of a wristwatch. And you say the watch should show 3:30. And what you get is 10 after 10. Why? Because the training material always shows watches which shows 10 after 10. And because a lack of understanding what a wristwatch is, you don't get the 3:30. So how is that with physics? How can you train it, or what you're doing with Gen AI tools to let them have a better understanding of the physical reality?
Maybe let's stuck to exactly this problem, right? The wrong expectation is that with one question, you always get the perfect answer. This is the same for a real organization. You cannot expect with a complex question to go to somebody and just get the perfect solution at the first shot. If you approach a ChatGPT, for example, to not directly create an image, but rather drawing a concept of a watch, then writing an algorithm to translate my input into the concrete angles, for example, you would get a perfect result, right? And
Yeah.
this is the underlying, let's say, capabilities that we bring into projects to show you that maybe you need not 1 step rather than 10 steps. Maybe you need 2 or 3, let's say, results in between that you store, that you review, that you work with, but then you're able to solve exactly this problem.
Yeah,
Okay.
and this
Okay.
is
Got
also what you get out of the box already, but we can control it much better. It's like the combination of simulation, of calculation, so programming, coding. I mean, nothing else. AI can work with physics very well. If you interconnect it to a sandbox where then a Python script is running with physical libraries, and then you can calculate the correct physics and do the AI part to maybe the creativity or the automation stuff would be tedious if you do would all programming that. So the combination of simulation of tools that we know with the AI is the real power. And this is also the strength, especially in engineering. Maybe for poem writing, you don't need it, but especially for engineering, you need it. And to orchestrate these interactions, this is kind of our core know-how.
Okay, got you. So that means in this concrete example which I made, you have first of all to explain how a watch is working and how a watch is signaling the time and what the representation of angles of the levers is, and then you will get your picture which you are looking for. But you should not expect that the Gen AI knows that, so to speak, by nature. You have first of all to introduce this concept, and then you can get it.
Yeah. And by the way, the new model can also do it by themselves. So they have recognized it now. You can also generate a complete full glass of wine and also a watch that can show any time.
Of course. I mean, in the end, this is nothing else than adjusting the system to that kind of use cases. And this is exactly what you do when it is a complex engineering problem. You have to adapt the system to learn that kind of engineering which is necessary there, that kind of physics, and then they can obviously apply it.
And the beauty of it, sorry, Rick.
I mean, at the end of the day, this is the part where our intersection is so meaningful and so valuable, because if you have a complex task, you have to break it down into smaller solvable tasks, right? And you need for that the domain understanding, the domain experience. What does it actually mean? You cannot solve it with just the understanding of AI, right? You can maybe be one of the best to build up a system to fine tune it, but if you don't understand the problem itself and you can break it down into solvable steps, it's worthless, so to say.
I mean, that is exactly what Gemini is doing as Google is doing. They adapt Gemini, for example, to design molecules, and of course they have to train it with that specific problem, but then they can use it and obviously extremely successful also with creating new materials. They have to integrate that kind of physics or chemistry, it's more physics, that kind of physics in the system, and then the system can apply it. I have a question here from the audience, and I think that is something which triggers other too. The question is whether you're using general LLMs or more specific models. I think you have already answered that, but just say it again, please.
Yeah, maybe I can take it. So to be honest, we are in a technology that is so fast paced that everything we are saying today could be or have to be corrected in 2 months, right?
Yeah.
Just to be transparent and honest, I mean, the whole field of fine tuning or even creating complete new models from scratch takes a lot of resources in the meaning of energy, and also the costs of the TPUs and GPUs. What we often expect that with a good prompt engineering, with good examples, with a good workflow, with a good understanding of the problem, we are already capable of building on existing models to solve the problem, right? Which means that instead of the, let's say, traditional view that a lot of training data would be the best case, often to give methodology knowledge, process knowledge to the LLM is already sufficient.
Mm-hmm.
Yeah, we can, so far we have solved all our customer requests with normal models. So we don't have an engineering specific model. There were cases where we had to admit that the LLM couldn't do it. So there would be, especially in the mechanical design area, there is a pretty difficult, because an LLM has never learned what are the dedicated steps to design a certain thing. So this is pretty difficult to get it out. You see examples if you connect an LLM with an MCP to a CAD system. and it's not really, it's like a 5 years old kid sitting in front of the funny buttons of a CAD system and clicking something. Yeah. So it is not really working. So this would be an area where a dedicated LLM would make sense, but all the other use cases we have, we take standard LLM.
Yeah, and we have already that kind of technology for especially for mechanical engineering. We have dedicated AI systems which are also inventing on mechanical engineering stuff. So this is simply you choose simply the tool which fits to the concrete problem. I mean, that is obvious.
Yeah, there are also some tricks. You can also overcome these hurdle from LLMs by giving them the right boundaries by libraries or other things, so it then can design. So, and this also what we do is say, what does the LLM need? We have a lot of examples. Rick also has some videos about, we didn't bring it today, but what we can show is also the take of creativity in designing a system, and also not only designing, but also operating the software, complex software to it. So which is not real creativity operating the software, but designing the system and also knowing what the components made of. Maybe Rick, you want to share this and explain it.
Yeah. So I think the underlying thing is maybe we can have a look into this video on the slide as well, as you should use it as an assistant system, right? What you see here is a typical software which you use for creating, let's say, the description of the structure and the behavior of a technical system itself. It's often used where you have complex system at all. And what we have here is then the ability, same as for software, that you have some kind of a co-pilot that is always there, that just helps you with the drafting, with the first initial steps, which before AI would take really a lot of time. Maybe if you can start the video, I can briefly explain what we're seeing here. Usually, engineers use these very complex tools. They take really hours and hours to build perfect system models, right? To make a very formal description of what it should do. With the help of a chat assistant, you can use just natural language, right? To type in what you would expect. The same what we see in the huge trend of vibe coding right away, right? In vibe coding, now people, still experts, use it to just create stuff like boilerplate stuff very fast and focus on the new stuff, on the new edge cases that you want to implement. And here we see exactly the same. And this maybe can make a step back to the question where we see this is capable of doing with a, let's say, out of the box, still state-of-the-art model. If you are able to understand what engineers do, the methodology, where to put what, how to use a tool, understand the special data formats and IT systems, but then using assisting model to make an agentic system in the backend to empower the engineer to do it faster, better, and focus on the crucial system, I would say, decisions, and make a good and more sophisticated architecture at the end of the day.
Wow.
And this is, I would say, from the scope, the two ends. We often start with Copilot. It's available. We are helping to have the right thing within, I would say, hours, till the point where you say, okay, now if I understand, I see the benefits, I see the value, then we come to the integration on the other scope, and that we say we can integrate all of this knowledge into professional IT solutions, as you can see here as an integration into an existing tool.
Okay, got you. Wonderful. That is, I mean, that gives a certain impression what's going on there and how that really concrete works. So, because I mean, many decision makers, when they hear in companies, when they hear AI adoption, then it comes with huge costs and big projects, big budgets. They have a certain bad experience typically from introducing a software like SAP or whatever, or CRM software, and because simply the processes were not there, and then the software introduction costs a lot of money. So what is your approach on that? Can that be also what you explain here? Can that be also used in, let's say, smaller budgets, in more project-based, more practical? How are you working with R&D teams?
Yeah, so that's a very good question. So this is completely different with AI than recent or other projects. So in the past years, I also have introduced PLM system or systems engineering, and the big problem with that is that you need to do a lot of upfront investment in resources, but also money. You need to buy the software, you need to train the key users, then you do also kind of a transition change management process alongside, with consultants. So it costs several hundred thousands of euros. So, and this is completely different with AI. Of course, because you can start completely different. Of course, you need kind of a training, you need to do something, but it can be very small and can also be decentralized. And you should also do this decentralized, not only centralize a big project with that. So for that, and if you like to share that, we have different steps how you can use AI from a customer perspective. So it's not the complexity of the AI, but it's the complexity of the user. And the easiest way to use AI is if it is integrated in a tool. So we've compared it like how you compare, like how you prepare foods. So the easiest way to get some food is a instant soup. You pour water on it, and then you're ready to eat. Yeah.
You know my children.
Yeah, exactly. So, and it's like with the AI tools, everybody knows about that. You may know the image treatment programs. You have a button where you can click on, and then it's removing the background. Yeah, it's a kind of AI algorithms doing that, but you don't need to have any clue how it's working. You just press a button. So this is a bit comparable with that. And there are already engineering tools or tool integration out, and we have just shown one in a video. So you don't need to step in a new tool which was developed by a startup. You can use your current engineering tool, and we are building you a plugin on top of that, and you've just seen it in the video how it works. So this is a very easy implementation, and of course you just need the plugin installment and a bit of training on the plugin, but it's not more than some days. So this is the easiest way to start with AI in your company. The next level would then be, if what we've discussed is using a chat window. A chat window, of course, everybody knows how to handle. That's the fact of ease of use, how they made it. But in engineering, it gets a bit more difficult, especially if you want to concrete answers and so on. We've talked about temperature. So what you need here is 1 or 2 days training on that, how you write the correct prompts, how you do MCP, so connecting tools to that and so on. It's a bit complicated, but it's not more complicated than a meal kit. So once you've done this 1 or 2 times, you can easily handle it. So this is what we also suggest to companies: get some training on that, give us some use cases, we build you the first prompt, and then you're ready to go by your own. So the next complexity level then would be that you want more capabilities. Yeah, you're not sufficient and satisfied anymore with just a text output. So you want the AI to handle something, as you have seen in our video. So then you need an AI agent, which is capable of handling a tool, of reading inputs, maybe from your SAP system, whatever. You need some connectors to it. So then we talk more about an AI agent. But also here, if you're in the Copilot work, you can easily build your own. It is a bit more complex than meal kit, but not more complex than cooking something with a recipe. So we show you this sometimes, and then you're ready to go. Then, of course, if you have even more complex use cases, you need a step further with then the combination of different agents. So we call this AI agent automation. And this is really a bigger step because it's more running like a restaurant. So you're not doing this next to your job. So this is a bit more complex. However, what we see right now, the hurdle by AI is reducing this hurdle, because these automation expertise, the AI is doing a lot of it for you. So, and then, all the other topic are really use case specific. You cannot use low code environments anymore. You need to really code. You may also grab into the AI itself. So what training, fine tuning, whatever, what we've discussed. So we put it all under the hood of being a chef, a 3-star chef cook, knowing very well how to feed the hens and chicken so the eggs are tasty. So this is very complex things then. And now the interesting point is the last bar here. Of course, tools you have to buy them, but all the rest you can make by your own. And I just yesterday come from a company. They have hired a kind of AI automation expert in their company, and they are building also these automation workflows themselves. So they have invested in it. Here's the make or buy decision. You can have a company is doing that for you, or we are doing that for you. So this is how you can have different levels of complexity, and there are a lot of use cases, especially here in the 3 first areas, which are pretty easy to implement. No need for a big setup, something like this.
Yeah, and I think I would assume that it makes absolutely sense simply to test that and to dig a bit deeper than when the first results are satisfying or astonishing, and then it is simply. I mean, I had a wonderful discussion with a company from the CTO forum, and I wanted to. We have a funded workshop series, a webinar, how to apply AI for generating inventive solutions. And they told me that cannot work. Okay, so the company, in this case, the IP representative, head of IP, told me this cannot work in that case, and therefore they don't want to invest an hour in such a webinar. I mean, it was free of charge. The investment was an hour to get the introduction, and that tells me that sometimes it's crazy the fear of engineers, of technicians, to be confronted with that kind of tools. And at the end, what you tell us here is that you can start very small and just can get a certain introduction to it before you invest more and go deeper into the field. And I think that makes absolutely sense.
Yeah. Most of our projects, when starting with a customer, are less than a week in total working time.
Brilliant.
Yeah.
So I have one topic which is obviously based on my IP world, but also in the engineering world, which is about secrecy and trade secrets, and at the end, when you want to get a patent, you don't have to disclose your solution in advance. You know, that's a big issue. And so how can you implement a certain level of secrecy when you work with customers, with clients in a project? What is your approach on that?
Rick, you wanna, or shall I explain it?
Yeah, maybe I would say, first of all, we are working with engineers. They are working on the stuff that came into the market in 5 years. So everybody's afraid of their IP, and it's totally reasonable. And we obviously know the main concern is there, and here comes the big. But there are ways how to protect it, I would say. Maybe I can step a little bit into the technical world, and maybe then Thomas can also give us a little bit view from the regulatory perspective on that. But just from the technical perspective, I would say a lot of companies, even if they're corporate or SMEs, are already on their cloud transition or on cloud journey, right? They're using Outlook, they're using some kind like SharePoint or Teams, so they're already proving on a big hyperscaler-based infrastructure, right? And nowadays we have popular startups. One example is OpenAI, right? And maybe it's not a startup anymore; it's a scale-up, and they don't really trust.
It's a 60 billion startup. Okay.
Yeah. but at the end of the day, they're building these foundational models. And it's too simple to say it's a file, but you can license these models. And that's what you see from the hyperscaler side. All of the hyperscalers highly investing in these scale-ups, in these grown-ups, to get these models, right? And then they put the model into the technical, the deployment, the technical infrastructure of their clouds. So they're providing the TPUs, the GPUs, so the computing power, and have the models. And then you are still in the same situation where you put your files or your documentation or your communication, right? So you get the let's say trust from a hyperscaler that your data is secure, that is only in your, let's say, tenant, that you have the same kind of data privacy rules that apply also on your communication, right? And obviously, there are definitely industries where this is not enough. But I would say for a lot of companies, this is more than sufficient. And also depend on what you put into it, right? And how you, let's say, put the data retention. Because what we often do is we just make sure that it's so-called statelets. You can assume it as a function. Something goes in and something goes out, often text and text. But it's just in the time where you put it in and out. It's not retended. It's deleted right afterwards. And if you really need high privacy, in the case of nothing can or should go out, let's say really the facility of a company, it's also capable of hosting it on your own. You need expertise. You need a good infrastructure, so compute power that can be done. But then we have a lot of, let's say, more or less open or open source models that you directly can get. They are not as good as the state-of-the-art models that you get at a hyperscaler. But what you can do is you can look for the use case and you can say, for this specific case, is it good enough, right? And this is a kind of decision journey where we help, right? So often we say, let's use synthetic data. Let's use data that is not at the core at your IP. Test it with a chat window. You get the first insight result, good feeling if it's working, and then takes the next step. And this was Thomas mean with this project is very fast. So wrap it up. Sorry for the long monologue, but yeah, you can make it secure.
Yeah, obviously. I mean, I'm not in doubt. I just asked that because many people out there have their, let's say, they are aware about that, but most of them have never heard the term tenant and what a tenant is and how it works and that it is already implemented. And of course, they have sometimes they have heard about the AI is using your data to become better, and then they are dramatically alert. And I would say that is a problem which can be relatively easy solved.
At a closer look, it's not a problem. As Rick said, I put it a bit different word. If you have made your decision to work with the cloud already, so you are using Office 360, 65, or you're using Google Cloud, whatever, then you made your decision. It's not changing if you add an AI to it. Your data is already in the cloud and is impacted by US Cloud Act already. So the potential risk of the US government having a claim on your data is potentially there. Of course, there are also statements of Microsoft and also AWS. They've said this never happened so far. Yeah, of course, there's these potential risks, but this does not change if you use AI or not. If you are putting your AI access into your Office or a cloud tenant, so it's actually Azure AI Foundry thing, what you can set up there, but it's in your covered and protected environment. Though this doesn't change. Of course, if you now contract a direct seed or an API with OpenAI or Anthropic, then you have a next US company with these potential risks. But it is not larger than, if you're not using cloud so far, of course, that's then a step to consider. But most companies already using.
And at the end, you can also run it locally. So it's even that is always an option when you want to be as safe as possible. Yeah. Rick, Thomas, thank you very much for that fascinating discussion today on AI-powered engineering. Henry Wang, one of our ambassadors, he is from Hong Kong, has a request. He would like to get a summary article about our discussion. Maybe that's a good idea to make a blog post on that discussion and your perspective. So quite interesting and fascinating, and changing engineering forever. So it's not the same as it was without AI. So for all the others out there, we are still open for new IP subject matter experts. We expand, and when you're interested to come in that program, we are happy to work with you, with European companies. You get the link in our chat to this SAP IP Business Talk. So thank you very much, Rick, Thomas. Have a great time. And it would be brilliant when you take the time in the after show party on LinkedIn just to answer the questions and give additional material when there is something available. So thank you very much. Bye-bye. Have a great time.
Bye-bye.
Thanks for having us. Bye.
Thank you for having us. Thank you.